Hello and welcome to 15.1 Ionic Bonding. We're going to start off by talking about ions. First, we have cations, which are positively charged. A cation is when an element loses one of its valence electrons to become positively charged because it loses a negatively charged electron. So sodium, it has one valence electron. If it loses that, it goes down a shell and it becomes a sodium ion, which has one positive charge because it lost one electron. Then we have anions, which are negatively charged. Anions are when elements gain electrons. So in this case, oxygen gained two electrons to become an oxide ion, which has a negative 2 charge. In both these cases, the atoms are trying to create a full octet to become as stable as possible. So in this case, sodium lost one electron to go down a lower energy level to have a full 8 octet on this energy level. An oxide gained 2 electrons to have a full octet here. And that makes them more stable than they would be, but then gives them a charge of either positive or negative if they are cations or anions, respectively. So we're now going to talk about Lewis dot diagrams, which we use to represent the valence electrons that an atom has. The dots around the symbol of the element is the number of valence electrons that atom has. So to write a Lewis diagram, you write the element symbol and then determine the number of valence electrons. Then, using dots, you place the electrons around the element symbol, and the dots should be spread over 4 sides. Dots don't start to be paired until all sides have at least one dot. So, for example, this is how we would do chlorine. So the symbol for chlorine is Cl, and chlorine has 7 valence electrons because it is a halogen. So we do 1, 2, 3, 4, going all the way around the outside before we double up on any one side. Then we do 5, 6, 7. And that is the Lewis dot diagram for chlorine. Another example, let's do sodium. So the symbol for sodium is Na, and sodium has 1 valence electron. So you would just put 1, like that. If instead we had a chloride ion instead of chlorine, well, we know that the chloride ion, we want Cl, we want chlorine to have a full octet of valence electrons. So we would add 1 electron, right? So it instead has 8 valence electrons, like that. And then we put these square brackets around the drawing and then write the charge that the element has when we're doing an ion. So for chloride, we're adding 1 electron to make it stable in the ion form. So we write these square brackets and then we say it has a charge of -1 with the negative sign. Then if we had a sodium ion, similarly, we would remove 1 electron from the outside. So sodium has none on this shell of its valence shell. Technically, it's encoding so it has 8 valence electrons, but in the Lewis dot diagram, we would just write it so it has none on its outer shell because it has lost the only one that it had. And then same thing, we draw square brackets and then put the positive symbol to represent it has a charge of 1. And that's how you draw Lewis diagrams. So, ionic compounds themselves are always formed between a metal ion, which is our cation that loses electrons, and a nonmetal ion, which is our anion that gain electrons. So, a sodium ion and a chlorine ion would come together to make NaCl. Electrons are transferred from the metal to the nonmetal. So sodium wants to lose one electron, chlorine wants to gain one electron. Sodium gives its electron to chlorine, making both of them stable, but then giving one a positive charge and one a negative charge. That brings them together. That is what attracts. The ions are then attracted to each other because one's positive and one's negative now to form an ionic bond. In a solid state, ionic compounds form crystals that have an alternating arrangement of positively charged ions and negatively charged ions. So you can see here, this is the crystal lattice of NaCl. They are hard, brittle, and have high melting points. So, ionic bonding involves three main steps. The loss of electrons by metal, it's the metal loses its electrons, which is the ionization energy that we talked about in our trends of the periodic table. An element losing an electron requires a certain amount of ionization energy. Then the second step, is the gain of electrons by the nonmetal, which is the electron affinity, the energy produced when a atom gains an electron. Then finally, there's an attraction between the positive and the negative ions, which is the bond energy, the forming of the bond. And it's this positive and negative attraction between the ions that creates the ionic bond that brings them together and then forms the compound. So let's draw a Lewis dot structure for ionic bonds instead of just a single atom or a single ion. In this case, we want to represent the bond between calcium and fluorine. And we start off doing what we did last time. So we draw calcium, the symbol for calcium, Ca, and then we draw its valence electrons, which in calcium's case is 2. Then we draw fluorine. We draw its valence electrons, which are 7. Then we know calcium wants to lose its 2 electrons and fluorine wants 1 electron. So how we draw this donation of electrons is through an arrow. An arrow from 1 electron going into the empty space of the atom that is the acceptor. Donator going to the acceptor. Like that. What we would notice here, though, is fluorine can only accept 1 electron, and now this fluorine is stable because it has 8. But calcium is still not stable. It still has 1 electron. So we need a second fluorine atom that then takes this electron. So this is the first step. If you remember, our first 2 steps are the electron gets lost by one and then accepted by the other. Then, how you'd write this, so this is the first step. You'd write this for your Lewis dot structure. You then write an equal sign, and then we go to the actual charge and bonding step, which is calcium now has a charge of 2 plus. So you'd write it lost both its electrons, and then it has a 2 plus charge. And then it's bonded to 1 fluorine, which has a negative charge and a full octet. And then it's bonded to another fluorine, which has a negative charge and a full octet. When you are writing the Lewis dot diagram for an ionic bond, you have to have both parts. So you would have this part of arrows being drawn, you'd have an equal sign, and then you'd write this part that shows the positive and negative charges causing the ionic bond, like this. All right? So connecting it back to our steps, we also can write it out as calcium plus energy creates the calcium ion and 2 free electrons. That is our ionization energy. This energy that it takes to create the calcium ion, to have it lose 2 electrons, is our first and second ionization energies. Then fluorine plus an electron creates the energy in a fluoride ion, which is our electron affinity. the energy that is produced when a atom gains an electron, and that would be times two because we know we have two fluorines in this situation. Then finally, the ionic interactions, we have calcium with a 2 plus charge reacts with two fluorines to create calcium fluoride, and that is the overall ionic equations altogether. All right, thank you so much for listening, and I hope you have a good day.